Okay, question 2E3 from Statistical Rethinking, second edition. Which of the expressions below correspond to the statement, the probability that it is Monday given that it is raining? So before we go through the options, let's just try to come up with our own expression here. So again, we have a conditional probability because we want to know the condition of one event, that it is Monday, given that we already know about the second event, that it is raining. So let's go ahead and write our own expression here. So the probability that it is Monday given that it is raining. Okay, so now let's go through our potential answers here. And right away we see that number 1 is correct. That matches what we came up with on by ourselves. The second option here, again, is a conditional probability, but it is reversing the things, reversing what we want. So rather than the probability of it being Monday, given that it is raining, it wants to know the probability of it being raining, given that we know it's Monday. So that's incorrect. Okay. The third one here is also incorrect, but it's incorrect for an interesting reason. We'll get there in a second here. So, but this is a conditional probability. The probability that it's raining given that it's Monday multiplied by the probability of it being Monday. So you may not recognize it right away, but this is actually a joint probability statement. So remember, a joint probability statement says, what is the probability of these two events or more events happening at the same time, right? So a conditional probability, we know about one of the events, or we're assuming that one of the events is true. Or has happened, but a joint probability says what is the probability of both of these happening at the same time. And so we might write the probability of it raining and being Monday, and this is exactly the same thing. The order doesn't matter with joint probabilities. This is the same thing of it being Monday. Sorry. Not a conditional probability. Okay, so these two statements are equivalent. Let me get rid of that there. Okay, so it turns out that one of the ways that we can write a joint probability is, well, exactly what we have is option 3 there. We can have, but I'm going to reverse the order just to explain it a little bit. We can have the probability of it being Monday times the probability of it raining given that it's Monday. And this is the same expression as, or I'm sorry, it's not the same expression, it's a different expression, but equaling the same thing. Okay, of rain times the probability of it being Monday given rain. Okay, so these are all different ways of expressing the same joint probability here. So if hopefully you can kind of make sense of this, but what it's saying is, okay, I want to know the probability of these two events, neither of which I'm sure about, occurring at the same time or together. And so one way that you could get both it being Monday and raining is you could say, well, what is the probability of it being Monday? And then for all times that it's Monday, what is the probability of it raining on one of those Mondays? Okay. And conversely, I could also say, again, if I want to say or if I want to know the probability of it raining and it being Monday, I can say, okay, we'll just take all instances in which it's Monday, and how many of those times is it Monday, or I'm sorry, take all the instances in which it's raining, and of those instances that it's raining, which of those occur on Monday? Okay, and so these are all just ways of expressing a joint probability. But getting back to our potential answers here, this is a joint probability. It's not a conditional probability, and so it is incorrect. Okay, so now we go down to number 4, and we see basically the same joint probability, but now it's being divided by rain, or divided by the probability of rain. Okay, so this turns out to be correct, and I want to explain why this is a correct answer. Okay. Okay. So we've already established that one of the correct answers is the probability of it being Monday, given that it is raining. And now I've also said that number 4 here is a correct answer, and this is just a statement of Bayes' theorem. So I could say, I could say that the probability of Monday, given that it is raining, by Bayes' theorem is equal to, well, exactly what we have there. The probability of rain given Monday times the probability of it being Monday, and all of that divided by the probability of rain. Okay, this is just a statement of Bayes' theorem, but now just to kind of continue drawing some parallels here, what do we see here in the numerator? Well, the numerator is a joint probability. It's the probability of rain and Monday. And so altogether, this is the probability of rain and Monday, given that it is rain. And so now I could also say that this is, taking our joint probability expressions up here, I could say that this is equivalently equal to, or equivalent to, rain and Monday, or Monday and rain, divided by the probability of rain. And these are all equally valid expressions of the conditional probability. Okay. Finally, option number 5 here, the probability of Monday, given that it is raining, times the probability of rain divided by the probability of Monday. So you'll notice that this is basically just flipping the two events from the previously correct answer. So this is incorrect, okay? But this is also a statement of Bayes' theorem. But what is the conditional probability that number 5 is representing? Well, number 5 is representing, so if we just kind of pattern match here, number 5 is representing the probability of rain given Monday. Okay, and so again, we can write this one as the probability of Monday given rain times the probability of rain, and then all of that divided by the probability of Monday. Okay, I think that's where well, actually, I want to do one more thing here. I want to derive Bayes' rule for you, and the way that we're going to derive it is from these conditional probability statements here. So let me scroll down. Okay, so let me start that over. So remember that the probability of, I'm just going to use one letter here, probability of rain and Monday, this equals, it's the same thing as saying the probability of Monday and rain. Okay, well, this equals the probability of rain given Monday times the probability of it being Monday, or I could equivalently say that this joint probability is equal to the probability of Monday, given that it is raining, times the probability that it is raining. Okay? So now, if I want to solve for one of these, so I'm going to try to solve for the conditional probability. What was our example? Monday, given that it is raining. So I want to solve for this term right here. Well, it's as easy as dividing through by the probability of rain. So I can say that the probability of Monday, given that it is raining, equals everything over here on the right-hand side, probability of rain given Monday times the probability of Monday divided by the probability of rain. Okay, and if you'll notice, this is what we had up here, right? So the probability of rain on Monday times the probability of Monday, probability of rain on Monday, probability of rain given Monday times the probability of Monday divided by the probability of rain.